And here we are. I was gifted, I was gifted with an advanced electronic piano, but for which there wasn't the right connector providing 13.5 volts of input. But I had a 14 volt one, which it was sufficient to scale down. Now I removed the plug-in, for which no one compatible plugger I had. I did the soldering myself, and it's here. I am testing the voltage scale down thing. It's a pretty practical technique which doesn't involve calculations, because I'm a little bit fed up with them. And well, we have an adjustable resistance, can be adjusted with this. This is what the 14 volts produces, but we can scale it down to lower value, adjustable, and we turn it down to the minimum, which barely corresponds to 13 or something like that. We plug it into the system. When it's reassembled, we start to turn it on upwards very, very slowly until it will reach the threshold at which the tension regulator circuit at the heart of every advanced digital device, especially if it's audiophile, works. And I realized that I want to be an electronic engineer. Why I didn't think of it before? Very fine. Clearly we needed a printed board circuit style of thing. A quick work, but it does a job. Essentially, this is completely disconnected, therefore these two wires do not connect at all. So they don't represent anything in the circuit, because it's disconnected here. I have checked the plan. Now, when connected, this acts as a resistor. Its resistance may vary, but these fluctuations are minimal and are corrected. We don't enter the details. We have to put into series another resistance to scale down the voltage. That's the scheme of a simple voltage divider, where this represents resistance number 1 and this is number 2. But in order to test how the overall thing will work on this, we use a simple LED-based test circuit. By turning this, which now it's on the lowest level, we can increase the voltage, because we are decreasing the resistance of this. Essentially, a flat screwdriver, and we turn it. Lowest, highest. There are some fluctuations because of the imperfection in the connection, but that will be corrected afterwards. Now, decrease, increase, maximum. The difference should be visible on the camera footage. Minimum value, maximum value. That's perfectly fine. Okay, it's now time to test. I said earlier, when the tension division doesn't give enough tension to this starts to misbehave. Now this consumes a bit too much for this resistance, but we can replace this. Now I go for becoming an prototype designer specialized in FPGA technology. I hope it will work. It works as to the subject, as to the job market. Well, there nothing works in the present situation, but FPGA designing Verilog, complex digital systems, maybe that reserve card, the Jolly, will bring to some result. Some electronics is already bringing to this result, to recover and get to work an electric piano of which the power supplier was lost, and I was given it for free, and I need it because my MIDI file editor program, Rosa Garden for Linux, doesn't have sound. Sometimes Linux makes jokes with sound, but no problem. To an electronics engineering background, one can certainly understand how to get on with a simple strategy of slowing down what is being written as to music composition, because music scores are nothing but a more human readable time diagram. The whole musical song is like a little bit, when it's being composed, is like designing a complex digital system where Verilog, or maybe VHDL, I don't know VHDL, but just Verilog, allows to do these things. There is a single note which corresponds in our analogy to the single logical block, and there are boxes which contain something more abstractly described, and then there are big black boxes which contain complex systems of whose connection we can start designing again. And so there are rules, but one is also free to write completely nonsense things, but also to write harmonic things. And here, this was Simon, alias the nerd of algorithms, and this was a video log. End of record.